Next, we revisit the employee class, the abstract class called employee, and this time, instead of just extending class object, we're also going to implement the payable interface, which you can see here at the end of the first line of the abstract class definition. Now, every employee type, because class employee implements payable, will also inherit that relationship. So any subclass of employee can also say now that objects of that class are also payable objects in addition to being employees. Now, for all of our employees, which in this example will be one other type, we have strings representing the first name, last name, and social security number, a constructor to initialize those values, set and get methods for each of those values, so you see all of those here. And then at the bottom of the class, we have a toString method, which gives us a string representation of the first name, the last name, and the social security number. And then you'll see this comment at the bottom of the class that says, note that we do not provide payable method get payment amount here, so this class must be declared abstract to avoid a compilation error. If you think back to our employee hierarchy when we had the earnings abstract method, it didn't make sense to define how to calculate the earnings in the employee class because we didn't know yet what type of employee it was, and therefore we didn't know what the appropriate earnings calculation was. In this case, we don't have an earnings method. However, we did say back at the beginning of the class that employee implements payable. Well, the requirement is that you either must define all of the methods in the payable interface or you must declare your class abstract. So basically what we're saying here is that you're not allowed to create objects of class employee. We are instead going to inherit or receive into this class the abstract version of the get payable amount method. We're not going to define it down below here. So we've put this comment in here just for documentation purposes, and instead what we're going to do is force any subclass of employee to define that method if in fact we want to have a concrete class. So for example, if we take a look at the salaried employee class, you can see here at line 4 that salaried employee extends employee. So a salaried employee is an employee, and because employee implements payable, a salaried employee is also a payable object. And what makes it a payable object is both the fact that it inherits the implements relationship from its superclass employee, and also the fact that at the bottom of the class here we've provided a version of the get payment amount method that determines how to calculate the payment amount for a salaried employee. So if you take a look at class salaried employee, you'll see that in addition to the inherited data, we have a weekly salary, double variable. We've got a constructor to initialize the pieces of data in a salaried employee, and remember once again the use of the super keyword to initialize the parts that came from the super class. We've provided set and get methods for the weekly salary. We've provided a toString method to give us a string representation of a salaried employee, and most importantly, we've provided the same public double return type get payment amount method that takes no parameters as was declared back in the payable interface. So now we've got classes called invoice and salaried employee, which are both concrete classes that are also implementations of the payable interface, and in our test program we're going to go ahead and create a collection of these two types of objects and show you the polymorphic behavior that also works with interfaces.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.